17. Yesterday we did page 16. So on page 17, Bert and Ernie are working on solving the inequality. So today's inequality is 4 times the absolute value of x plus 1 minus 2, and then we have this inequality symbol that is greater than, right? Greater than, but not the equal part to it, right? Okay? Greater than 6. So if you were to put these into Desmos graphing calculator separately, your first line would be that. Your second line would be that. Okay, so we're going to pretend like you're graphing them. They're going to look a little something like this. The absolute value I highlighted in yellow, that gives you the V. Kind of similar to what we had yesterday, right? Yesterday we had a quadratic, which gives you more of a U-shape, parabola shape. But we had it intersected by a line, okay? This time our line is flat at x equals 6. There's no slope on it, so it's not going up or down, okay? It says, how can the graph help to solve the inequality? 4 times the absolute value of x plus 1 minus 2 greater than 6, okay? So here's what I want you to notice for the difference from today on the difference of the graph from yesterday, okay? So the inequality symbol here is greater than, but if you flip back just one page to yesterday's graph, our symbol was less than, okay? So we want the parts of the parabola that are less than the line, the orange line. So the parts of the parabola that are less than the line are down in this area, right? Which when we solved it on the number line and when we checked it algebraically, we had all the numbers in here, but false for the numbers outside, right? So on today's graph, we want the solutions of the absolute value that are above the line, okay? So if here's our line, now we want greater than. So this whole lower part of the absolute value, when we check it algebraically, should be what? True or false? That part should be false, and these two parts, when we check numbers here and here, should be true, okay? And when we graph it on the number line, is it going to be overlapping in the middle or going opposite directions? It's going to be two parts, and that when I wrote it, I'm like, oh, that looks like it says 2 pants. It says 2 parts. There's going to be 2 parts that are going to be true, and that would be when x is less than 3, so this part over here, or when x is greater than 1, which is right here, going from here and above, okay? And if we test exactly those points, we're going to get something weird, okay? Did we do that in this class yesterday, or was that 6th grade? I can't remember. All right. So question 68 says, what if we didn't have a graph? How can we solve 4 times the absolute value of x plus 1 minus 2 is greater than 6? So algebraically, we'd add 2 to both sides, divide both sides by 4, and that would give us the absolute value of x plus 1 is greater than 2. So this is one of those weird little quirky pre-algebra things where you rewrite the inequality of an absolute value as 2 separate pieces. One saying x plus 1 is greater than 2, and then one saying x plus 1, and then you have to reverse the inequality to less than, and then you say the opposite of that number, Okay, so less than -2. And then you solve them separately. You do not always get opposite numbers. A lot of people think you just get opposite numbers. You don't. You subtract 1, so you're going to have x is greater than 1. That means you have an open circle on 1, shaded to the right. And for this one, when you subtract 1, you get -3, which is an open circle on -3, shaded to the left. Okay? So yesterday's, if you remember, had overlapping in the middle. This one has shading going opposite directions. Okay? Why? Because of the inequality symbol. If you look up at the top of this page, what was the inequality symbol on this one? Greater than, but not, it doesn't have the equal to part, okay? The one on the previous page was less than. Okay, so that's the major difference in how they're graphed and shaded. So you need to think about it logically, okay? If I have my absolute value and I have the line, I want the absolute value where it's, I'm pointing to it and it's, okay, where the absolute value is greater than that line of 6, okay? So here's the line. I want the absolute value parts that are greater. So here and here going on to infinity each direction. Okay? So part B down at the bottom is just where we're going to check the 3 different parts of the graph to see if we get true or false. And you guys already told me we should get true, false, true. Whereas yesterday we got false, true, false. Okay? So you're going to pick any number over in this area. I picked -5, plugged it in, back up to that original equation way up at the top of the page, and then just simplified. So I combined the -5 plus 1 to get -4. The absolute value of -4 is 4. 4 times 4 is 16, and 16 minus 2 is 14. And then on the right-hand side, we just had a 6. So is 14 greater than 6? Yes, it is, so we say true. I'll move it up just a little bit because I can see you guys writing fast. And then in the middle here, the easiest number to pick is usually 0. Not always, but if you ever have the opportunity to pick 0, pick 0, okay? Plug in 0. 0 plus 1 is 1. 4 times 1 is 4. And then 4 minus 2 is 2. So is 2 greater than 6? No, it's not. So you say false. And then for this region over here, you can pick any of these numbers, but I just picked 2 because it seemed easiest. So 2 plus 1 is 3. The absolute value of 3 is 3. 3 times 4 is 12, and 12 minus 2 is 10. So is 10 greater than 6? Yes, it is. So you say true.